All right, so this is the second half of the problem we worked on at the end of class last time. And just to remind you that we were writing the equations for shear force and bending moment, and because the load was discontinuous over the first 12 feet, we wrote an equation from x between 0 and 12, and then the load changed and became a different function, in this case 0, so we're going to have to write a second set of equations from 12 to 20, and that's where we are now. So let's see if I can squeeze this in here. So if I now look at a situation where I want my cut to be somewhere between 12 and 20, and I'll do that, we have to decide which side we're going to work, the left side or the right side.
Right.
I think we definitely want to work the right side. Now I worked the right side here too, to recall. The advantage there was I didn't need to find my reactions. I think even if I had decided to work the left-hand side here and found the reactions, when I got to this point, I think the right-hand side would have been the one you'd want to choose. So if I draw that free body diagram, you can see there's not a lot to consider. I just have the 20 kip force. Just so you remember that it's still happening at some distance x, and then the remaining piece, the section of our free body, would be 20 minus x. Then the only things left on our free body diagram would be the internal value for our shear, that's positive, and our moment. So all we do is apply equilibrium to this free body and we'll be good to go.
So, I don't know how significant this is, but I noticed on the ones we did for homework, it always asked for like 1 is less than x is less than 2. It wasn't 1 is less than or equal to x, less than or equal to 2. But like here, we do...
I think it'll be okay. Now the reason on the homework ones is if they say equal to, then it's right underneath the applied load, and we know what happens under the applied load, right? The shear is going to change exactly that amount.
Right.
So you don't get right to that point.
Okay. So if there's like a point load already there, you'll just do less than, and you wouldn't do it like actually equal to?
Yes.
Okay.
So in that case, you would have an equation that, like if this were that point you were talking about, you would get the x as far as you could just to the left of the force.
Okay. And
then your next set of equations would be on this side, and it would be as close from this side just to the right. So your shear equations will never account for this value right here. In fact, they would be different at that point by 20 kips. We could look at that in a minute if you want. I think one of your homework problems had that. So to finish this problem, we're just going to sum the moments at the cut to make sure it's in equilibrium using right-hand rule. So here, our moment is going to be what? Positive or negative? Negative. And then the moment about the cut face, this 20 kip force creates positive or negative moment. Also negative, so that's going to be 20 kips, and the moment arm is 20 minus x. Oops. So it looks like the moment as a function of x is negative 20 times 20 minus x, and those all have the units of kip feet. And then last, for this section, we'll sum forces in the y direction. And looking at our free body diagram, the shear force is acting up, and 20 kips is acting down. So our shear function is a constant, 20 kips. And if you look at the derivative of the moment, is it equal to the shear? Yeah. And the answer is yes. So that seems to work. Now, where these two things match, we ought to see some continuity. So at x equal 12, if you go up here to this moment expression, somebody put in x equal 12 there and tell me what you get. Hey, I'm gonna go back and call this moment 1 and call this moment 2. So what's the value for moment 1 at 12? If you put 12 in here, I get a negative 160. So moment 2 at x equal 12 is negative 160. Did that come out to be negative 160? Did? That's good. So there's, again, some ways to kind of make sure that things are working. I think the shear is going to be even easier. At x equal 12, you see this cancels out, you get 20, and this matches at 20. Now, you wouldn't be able to do that if at that point there was a applied force there. The difference would be that 20. So any other questions about this one? We just didn't get a chance to finish it last time. Okay.